Hey, hi everybody. It's me, Walter Wesley. I'm here to make a little movie, show my buddy Larry Jennings about the nature of the universe. And these ideas don't come exactly from me, but I get them from David LaPont, who did a great video called Primer Fields 1, 2, and 3. And Eric P. Dollard. You can go to ericpdollard.com and he explains some of this, but it's sort of a mix between the two thoughts. And Eric Dollard is an electrical engineer who he did a lot of observing of the sun, and also he's also the man to reproduce the most Tesla experiments. So I understand. He's just a great guy to listen to, Eric P. Dollard. I'll leave that in the comments. But what I wanted to explain is some fundamentals of the electric universe, as I understand it, at least a real simple way. I don't believe in black holes. I don't believe in quantum energy. I don't believe in quantum theory or relativity, nor do I subscribe to those theories. But what I do is I study the history of electricity and electrical engineering through Galvani, Faraday, Clerk to Maxwell, Tesla, and Steinmetz, Proteus Steinmetz, and Heaviside. And Eric B. Dollard is a way of combining this all and adding other new things to it. So I like to look what he's doing. But from this video that I saw from David LaPont, he reproduces basically images of the galaxies in his little vacuum tube, and it's really fascinating. And one thing he finds out that is everything comes to us, of course, by sunlight, and so by what I feel are waves. In my thinking, there is no wave-particle duality; it's all waves, and I talk about that in another lecture. But the energy seems to appear into the universe from another universe, basically as a point of electricity. You could think of this like the sun. The sun actually, when you look at the sun, it's actually totally black, solid black hole. I don't believe that there are black holes because we've never seen them. But the sun is a black entity surrounded by a mixture of hydrogen and helium that's igniting, and that's why the sun appears to be yellow and hot and bright like that, because that is nuclear discharging, but that's not what's happening on the inside of that atmosphere or on the so-called surface of the sun. We don't know what the surface of the sun is. We don't know it exists, whatever. But what we do know that it emanates energy. I think we can all believe that. And the energy is a kind of the sun is almost like an electrical transformer, and it transforms energy. And the reason is because electrical, when you have an electric charge, it emits a magnetic field at the same time, and the fields look like this. They're giant bowl structures like this, and one like this, and one like this, and these are magnetic fields. And that magnetic field has a north and a north-south orientation, and this one has a south-north orientation. So they're kind of like opposing fields. And I'll do that in some nice colors here. We got some purple, we got some orange. So this would designate the north to south field, arbitrary colors here, and the south to north field like that there. And then the upper north to south field would be up here and here. And lo and behold, our galaxy, with all its splendor and all that, this could be basically a schematic of the sun. You have to imagine these fields. These are fields here. You can't see them, but they exist, and they appear almost like a bowl-like structure. They're a bowl-like structure of magnetic fields. And and then here would be the lower magnetic field. And these basically go back in on themselves, and lead back. They come back out that way around the sides and come back in, and there's a big space here. And that is the structure. The structure of our galaxies are all fit around that. I make the statement then when New York Times said we found the black hole, we didn't find the black hole at all. We found a giant sun that's transforming electrical energy into this field. And what it looked like was a large donut. And the reason why it looked like a large donut is because in this area here, you have another toroid that's going around here like that, in the toroid space. Another that matter is ignited. In our own galaxy, which is a spiral galaxy, what we have is all the matter is being is in here for the most part. And this is sort of a wild guess based on stuff I'm told. If this was our galaxy, then the Earth is somewhere like up there or something like that. Or up there 20,000 miles out. I don't know, 20 million, billion. So that is the model of the nature of the universe. And the electron also exhibits this behavior as well too. And I'll have to do another video on that to show you how that works. But it shows that the wave-particle duality is not a wave-particle duality. It's a wave, and the wave is being affected by the other slit, basically, double slit experiment. You know that one. So that's it. That's the nature of the universe. I hope you liked it. Larry, I hope you like it. It's a big magnet. There are further analysis on this structure as well too, and that is if you take this structure here, if you take this structure and look at a schematic of it, and this one up here, it would, if you just cut that away, right? You get this. Can you see that? Yeah. Okay. You get this on that side. This cut away like this. This would not be here. This is like this. This is like this. That's how it travels. This travels like that. This travels like that. And then within the structures, there are substructures. Substructures are in here like that, and they also have something called that David LaPlante calls a flip ring here, where the magnetism basically is being put in like this, and it flips right there. So you have a pressure zone. You have a pressure zone that's bulging out like that, and another pressure zone up here, gotta get my colors right, that's bulging out like this. Basically like this. And when you have these galaxies that are seen from afar, that have these, that are like this or whatever, or called quasars, and they have these giant giant emanations coming out this way, like that. And you have these giant emanations that come out this way. That's a breakout in the containment zone. The containment zone basically is busting loose. That's well understood by electrical engineers as a failure when that bubble pops out. That's pretty well understood, and that will do that regularly, and that's why you get the brilliant light of the quasar, not because it's going around like a big lighthouse. That's not it at all. It's sitting there, it's blasting it out. It's blasting it out. And that donut hole that we saw in New York Times, you know, that looked like this, where they say there was a black hole emanating in the middle, because they try to confuse everybody with things they don't really know, or things that they know are based on incorrect assumptions. Is this space here, this is dark here, this is dark here, this is dark here. That would be looking on a structure like this, a spiral galaxy, looking boom, head on it. And so that is the end of this little short clip. And anybody else who gets a hold of this, I hope you've enjoyed it. Please put a like in there so I can, or like and definitely comment. I can answer your comments and, you know, find out if you felt this YouTube is interesting. So anyway, have a good day. Bye-bye, y'all. And here we go.